Greetings, everyone. I'm Capt. Pankaj Pahil. With 17 years of experience training pilots across the globe, I'm here to guide you through the intricacies of the DGCA syllabus. Let's get right into it.
Listen to this closely. Discipline in the skies begins with absolute mastery in the classroom. The exactness of your knowledge today guarantees the safety of your passengers tomorrow. Over my 17 years instructing from the right seat, I've seen it time and time again. Aviation, well, it isn't about guessing. It is about absolute precision. Today, we aren't just learning numbers to pass a test. We're literally building the foundation of your command.
So welcome to today's Ground School Explainer. We're going to dive right into the technicalities. Now, to make sure you actually retain this dense material, we're using a very specific framework. For every single topic, we'll go from concept to application right to the DGCA exam tip. Also, keep an eye on the color coding on the screen. Red, that means it's a critical safety limitation. Blue dictates regulatory procedures, and green highlights our standard operating procedures.
All right, here's our flight plan for this explainer. 1. Vertical separation standards. 2. Applying lateral separation. 3. Longitudinal time-based separation. 4. Distance-based separation methods. And 5. Surveillance and our exam summary. Let's kick things off with Section 1. Vertical separation standards. Let's start with a crucial regulatory concept. You'll see it there in blue text, composite separation. So what is this exactly? Well, it's a combination of both vertical and horizontal separation. The main concept here is that it uses minima that might be lower than the standard individual minimums. But, and this is absolutely key, guys, it is never less than half of those individual minimums. The strict application rule you've got to memorize is that composite separation shall only be applied based on regional air navigation agreements. You can't just, invent this on the fly. It has to be a predefined regional agreement, for sure.
Now, this table is basically the bedrock of vertical separation. So, standard nominal separation below flight level 290, that's 1,000 feet. But the moment you hit flight level 290 or climb above it, that standard separation suddenly doubles to 2,000 feet. Why? Well, it's because altimeter error naturally increases as the air gets thinner up at those high altitudes. However, notice that row coded in green. That's our standard operating procedure for RVSM, or Reduced Vertical Separation Minimum Airspace. If both your aircraft and the airspace you're in are RVSM compliant, we shrink that buffer right back down to 1,000 feet above flight level 290. Make sure you lock that transition at FL 290 into your memory for the exam.
Moving on to a very specific application, VMC climbs and descents. Under certain conditions, an ATC unit might clear a controlled flight to actually maintain its own separation. You'll notice the green coding there, indicating standard operating procedures. The conditions for this are super strict. It must be requested by the aircraft, it's got to be agreed to by the other pilot, you have to be operating in Class D or E airspace, and critically, it must be during daylight hours, no exceptions. Furthermore, this clearance is strictly limited to at or below 10,000 feet. Since you are taking full responsibility for the separation, you absolutely must maintain visual meteorological conditions. Okay, now from major DGCA exam tip. I put this in red because it represents a critical safety limitation. The exam is going to ask you, when severe turbulence is known to exist, when can an aircraft descend to a level vacated by another aircraft? Now, the standard rule is you can descend once they report vacating. But in severe turbulence, the application shifts drastically. Clearance must be withheld until the vacating aircraft has reported at or passing another level separated by the required minimum. Think about it. Severe turbulence can cause massive altitude deviations. We just don't take chances there. You wait for them to be fully established at the next level down.
All right, Section 2, applying lateral separation.
The most fundamental method here is geographic location. Just position reports confirming aircraft are flying over entirely different tracks. But the exam loves testing navigational aids. Take a look at the VOR diagram. The blue regulatory rule is this. For lateral separation using a VOR, both aircraft must be established on radials diverging by at least 15 degrees. But wait. Angular divergence alone isn't enough. You need actual physical distance to let those radials spread out. Therefore, at least one aircraft has to be 15 nautical miles or more away from the VOR facility.
Now let's contrast the VOR with the NDB, the non-directional beacon. Notice the divergence angle here? It's 30 degrees. Why the big difference? Well, this brilliantly illustrates the nature of the equipment itself. NDB signals are just way more susceptible to interference, like coastal refraction, compared to VORs. Because of that, the regulations require a much wider margin of safety. Here is your DGCA exam tip. VOR is 15 degrees at 15 nm. NDB is 30 degrees at 15 nm. Definitely do not mix those up on test day.
Let's move on to Section 3, longitudinal time-based separation.
Now this module is heavily data-driven, so stay with me. Notice the blue regulatory table here. The standard longitudinal time separation is 15 minutes. But if we have frequent position and speed updates from nav aids, we can actually reduce that to 10 minutes. And we can compress this even further if the leading aircraft is faster. If the leading aircraft is maintaining a true airspeed 20 knots faster than the succeeding aircraft, separation drops to 5 minutes. And if the leading aircraft has a massive 40-knot speed advantage, that separation drops to just 3 minutes. The logic is pretty simple. The faster aircraft is constantly pulling away, which increases the safety buffer every single second.
Let's define the actual geometry. A same track means the angular difference is less than 45 degrees. Easy enough, but look at the red critical rule for reciprocal tracks. This is where aircraft are flying directly toward each other with an angular difference greater than 135 degrees. The closure rates in this scenario are absolutely immense. So what's the rule? Where lateral separation is not provided, vertical separation must be provided for at least 10 minutes prior to and 10 minutes after the estimated time of passing. You really do not mess around with head-on traffic. 10 minutes before, 10 minutes after. Period.
Next up, Section 4, distance-based separation methods. Check out the standard operating procedures highlighted in green. When we're using DME or GNSS, the standard distance-based separation for aircraft on the same track and same level is 20 nautical miles. This is also true for crossing tracks with less than a 90-degree divergence. So, here's your exam application. When exactly does that 20 nm drop to 10 nm? There are two scenarios. First, just like with time, if the leading aircraft is 20 knots faster, the separation halves to 10 nm. Second, if one aircraft is climbing or descending through the level of another on the same track, the required distance, while vertical separation doesn't exist, is also 10 nm.
Finally, Section 5, surveillance and exam summary. Take a look at the blue 60 nautical mile threshold circle around the ground station. Inside that 60 nm radius, the surveillance is highly precise, which allows for a minimum horizontal separation of just 5 nautical miles. However, the exact moment you cross outside that 60 nm boundary from the radar or ADS-CV ground station, the beam has widened, the uncertainty slightly increases, and so the minimum separation jumps to 10 nautical miles. It's a simple rule. Inside 60 equals 5 nm. Outside 60 equals 10 nm. Let's actually test that immediately with question 25, straight from the syllabus. It asks, an ADS-B ground station is more than 110 nms from two aircraft at the same level. Only ADS-B is being used in a non-radar environment. What is the minimum safe distance? So, apply the concept we literally just learned. Is 110 nm inside or outside the 60 nm threshold? Well, it's far outside. Therefore, as you can see highlighted in green, the required safe separation distance is 10 nautical miles. Easy points on the exam if you remember the rule.
Wow, we've covered a tremendous amount of ground today. We went from composite vertical limits to precise angular track divergences, and finally to the critical thresholds of radar. Look, mastery of these exact minima isn't just about passing your DGCA exams. When you're sitting in the left seat thousands of feet in the air, traversing blind through the clouds at hundreds of knots, these numbers, they're the invisible shield that keeps your aircraft and literally every soul on board safe. Memorize them, understand them, respect them. Study hard, fly safe. Are you ready for your clearance?